Hi, good morning. And we've gone a little bit live a little bit early today, but every Thursday at 8 a.m. UK, we like to do a sort of live streaming webinar specifically for the members of our ZP Developer Zone. So thank you if you're joining this morning. I realize it's in the middle of a big essentially holiday season, so not expecting lots of people today, but if you do attend, thank you very much. If you're watching afterwards, thank you very much again. So let me sort of dive into the ZP Developer Zone webinar. So the ZP Developer Zone is intended to really help the community in their development and hopefully productization and commercialization of their biosensors. So we have things like the ZP Academy, where you can get free online training. We have these webinars, and we always do these webinars. I think there's not been a skip in webinars for over a year. We definitely have collaborations, both academic collaborations, and we have some of our ZP Developer Zone members joining us in April, so we look forward to that. People do ask us about how to get jobs at ZP, so it should be worth noting that I know it doesn't help some of the people with PhD and postdocs, but there is a PhD being advertised at the moment at the University of Birmingham, which hopefully you can find through the ZP website. And that is a good way into ZP, because that is at the University of Birmingham in the UK, and it's worth saying that that's very near one of our sites in Coventry. We obviously have our website, ZP Developer Zone. So we run a forum on there, and we ask you, look, if you've got any questions, technical questions, then please put them there. And then we actually have a workshop. So just for interest, there's a Biosensors Technology Conference on May the 22nd to May the 25th, and ZP is holding a workshop on May the 22nd. So we do also have practical workshops. So let's dive a little bit more into this now. Now, this week is a little bit unusual. We often talk quite a lot about, we're getting deep on the technical aspects of biosensor development. But I actually want to step back a little bit today and actually sort of talk about really sort of how you set up your experiments. Not so much your experiments, but how you set up your experimental database. How do you capture the value from your experiments? So I call this the Unlocking the Experimental Network Value, the ENV. I did put a video out about this a couple of days ago, but I wanted to make this one a bit more sort of relevant to people in the ZP Developer Zone. So the first thing is, what I understand is that, lots of people, when they're doing their research, they might actually just be a single sort of PhD on their own, at which point this idea of the experimental network value may not be so relevant. But I do feel like even then, lots of people are actually on what we call like a Horizon 2020 grants or Marie Curie grants, where there's actually quite a lot of researchers, maybe at different universities, who are all on the same project. But if you ask them, how connected are the experimentalists in terms of being able to see in real time each other's data, the answer is, I don't think I've ever seen it, to be honest with you. So I think it's actually quite low. So first of all, let me just define this experimental network value. Now, what I want the experimental network value to do is actually to basically accelerate the research and development process, make that more efficient, and then in the long run, basically benefit humanity, because it's in all our interests for R&D to be as efficient as possible, so that society can gain as much as possible from the discoveries. So if we take a single researcher who's really isolated, good morning Aftab, and we take a single researcher who's really isolated, then they have an EMV value of 0. Now, if that researcher is in a network of other experimentalists, then let's say there's 6 of them, then the ENV value of that is actually 15. Now, as I say, if you really are in a single project on your own, then having being networked and connected to the other people in the research process are maybe not so it's just not, they're not there, so you can't get the value. But I'm thinking about so many projects, actually you will have, one scientist taking care of one aspect of research, but that then ties in with another scientist doing another aspect of research. And so I think it's really useful to actually have these people connected and coordinated in a much better way. Now, this is critical in industry where we really can't afford, time is essentially money. So we do need everything to be as efficient as possible. So having everyone well connected is really important. Now, we connect everyone through Julie. I have talked about Julie in the past, and I've sort of said that Julie is an online database for the collection and sort of sharing and analysis of data, and that's what it is. It's at this moment it's a free database where it's particularly tailored towards people who are doing electrochemistry. But really, the features that are becoming more and more important to us is the ability to actually take data and share it with internal collaborators and external collaborators. And products like Dropbox and G Drive and OneDrive, they're just not designed for scientific experiments. They're not. They're documents, file sharing systems or file storage systems. They're not designed for experimentalists. So I want to get the ENV value really high. Now, if I bring together a group of something like 12 experimentalists and calculate the ENV value, it's got 66. So you can see that we have a very rapid rise in the value of the experimental network the more we connect them. I do think, and I'll say it again, that in universities you will have people on the same projects or even in industry, and there's no way of them readily seeing each other's work, at which point you could have 5 people in a lab, but the ENV value of it could be 0. Whereas if you've got 5 people in a lab and they're all well connected, and I would argue through Julie, then the ENV value is 15. So the problem is, in business, in startups, in institutions, in academia, we're not getting the full value from our experimental efforts. And if we've got external collaborators, I think it's even lower. So for example, at ZP now, we do have a lot of academic collaborations. So if you ask, people, well, where are you storing your data? You'll find it's actually up to the individual scientist often where the data is stored. But of course, if we're collaborating with people, we say, no, you use Julie, because if their data is uploading to Julie and then they share essentially that with us, we can see their data going up in real time, and that's really powerful for us. And it also means we can help them better. So as we set up our academic collaborations, we get everyone onto Julie. So, this is a common scenario. You can have 3 people in a lab, all, working away on similar projects or on the same project. And then you can have stakeholders, maybe not in the lab so much, but these people also want to know what's going on. And as I say, if they're not well connected through a cloud database system like Julie, then they really have a low experimental network value. But if we can get them connected, then the experiments are much more connected. Everyone can see what's going on. A failure here can help somebody with a success somewhere else. Now, the first thing that Julie does is, first of all, I'll talk about the worst case scenario. The worst case scenario is you can have 2 people in a laboratory, in a business, storing data in different places. One is on OneDrive, one's on G Drive, one's on Dropbox. Worst case scenario, one of them's actually using the hard disk of a computer. I find that much more rare these days, but it could be happening. Data could be going onto that computer, and actually it's not backed up in any way. So that is a really bad situation. So OneDrive, G Drive, and Dropbox. Now these seem like, I put my data there and everyone can see it. The problem with those systems are, that each scientist is free to have their own folders, and you can have a scenario where one university is on G Drive and another university is on Dropbox, or another university is on another system, or 2 businesses, one's on G Drive and one's on Dropbox. At that point, it's actually really hard to see each other's data. And even if you are on the same cloud drive, let's say it's G Drive, then one scientist could have their own folder system, and another scientist could have their own folder system. And in fact, when somebody like myself comes along and says, where is the data, it's actually really hard to find, and maybe even impossible. Because when I say impossible, even if a university or a business has a cloud data system, you can have you can have shared folders there, and you can have personal folders. And if it's in your personal folders, nobody else knows those exist, so that it could be impossible for me to find your data. The way you structure your data, it's not something that's overly taught, as an undergraduate, how to structure data. So people are just expected to kind of, know, and mostly I think they're just figuring it out, and they're mostly figuring out doing their PhD. So I think this unstructured sort of data collection is kind of worse during the PhD, and so I think it's good to fix that problem even now. Very hard to scale. What I mean by very hard to scale is the more people you bring into the research group or into the business who are doing experiments, the worse this situation becomes. And then it's very hard to collaborate with outside organizations. They don't know your structure, they don't know your nuances, your foibles, and so it's very hard for them to, even if you share the folders, to necessarily find the information. And you might be keeping information in different places. You might be keeping experimental notes one place and actual raw data in another place. So, it's very hard for outside collaborators to work with you when there's no structure to the data. What's happening most of the time, is that people are actually emailing it or outlooking it or slacking it across, at which point then they take out one set of data, send it across, and so that data is not in the context of all the other data. Something that struck me as well is there is a bit of a crisis in R&D, in papers, where people have found it very hard to repeat other people's papers. And I realized, electronic lab notebooks that can easily be shared. This provides the evidence that experiments took place, and it provides, the raw protocols which people actually did in the lab. So that really helps with the repeating of experiments. So for me, it's very scalable, because actually Julie, you can just, create a sign up. You can just get somebody to sign up. They use their email and their password, at which point they're into Julie. And, you can, as a new scientist joins the group, you can just have them sign up. It's really quite straightforward. So I think AFTAB's online, AFTAB, but I'm really thinking that I really want to start, as we build up our collaborations with our Indian colleagues, we're really going to get them onto Julie. It'll cost them nothing, and essentially we'll start organizing their data and allowing us to have good eyes on that data. Now, there's a structure to Julie. I do want to back up in a bit and say, look, the reason we're talking about this is because there is a problem that many startups, even mature businesses and academia, if you go and ask, the principal investigator, where's the data, they might not be able to readily tell you. Now, before we start unlocking that electronic network value, we have to actually say, what's the structure in Julie? So the structure in Julie is that we have essentially three hierarchies, or hierarchy of three. We have clusters, so that's the top level hierarchy. Under clusters, we create projects, and under projects, we create reports. Now, I think reports are the electronic lab notebook pages. Now, what happens is, in those electronic lab notebook pages, we can put electrochemical data, images, video, notes, in the form of text. We'll have dates in there, who did the work, why they were doing the work, what their conclusions were. So they build the content. But what happens is the experimental manager, this could be a professor at IIT Bombay, for example, they set up the clusters and the projects, and then they invite experimentalists, people in the lab, or people like ZP, to be able to view that data and contribute to that data, which happens essentially in the reports. So the structure is set up by the person who's really sort of passionate about the data and making sure they know where things are, and then they can have the doers essentially going in and generating the experimental results. So when we first started introducing Julie, we were introducing it because on an individual level, you could save your data, you could share your data, you could analyze your data, and we were very much focused on the individual's experience. But we've really broadened that now and actually said, this is much more than just the individual. This is how to bring individuals together in a way that makes the sum of all those individuals much greater than the individuals alone. And we call that the experimental network value. The more connected experimentalists and the more connected they are, then the higher the experimental network value. And it all starts off with structure. So if you go into Julie, the first thing you'll get after you log in is you'll see clusters. You'll see my clusters and clusters that are shared with me. So these are things that other people have essentially shared with me. Now you can create new clusters. There's just a little button. It looks like a folder with a little plus sign next to it. You can just create clusters. You can refresh the page, so you can just see if somebody added you to a cluster, then you can just do a quick refresh and it'll show you what clusters you're currently accessing. Now if I take this fish tag cluster and I click it, what I'm going to be met with is the project. So under fish tag at ZP we have a project called cortisol and a project called glucose. So at the top level we have clusters, underneath clusters we have projects. So that's a cluster called fish tag. Under here we have a project called glucose. This is a list of all the experiments in that project. Now it's probably worth seeing that there's probably about 25 experiments in that list. They're all clickable. There's a lot of detail behind each one, but there's several pages of it. So it really tells you, if I do some quick maths on this, it looks like I've got approximately 175-ish, 175 experiments in this project at the moment. You can soon lose control of things if you don't get on top of this at the very beginning. And I say, get a Julie account. They're free to get. They'll allow you to create clusters, projects, and the projects you can start putting your data. But then the power comes then when you can really collaborate with people. So under all these projects, which I go back one, they're searchable, by the way. That I can put words in here and it will search through the list. So that's really important as well. That it's not just I know where my data is. My data is also searchable. And so if you're AFTAB in India and you're working with a professor at IIT Bombay and you want to find a particular piece of data, it's hard to go through something like 175 pages worth of reports, but a quick search could actually help you narrow that down a bit. So they're searchable. And then we actually have the reports themselves. So if we click onto a report, you'll have sort of metadata, test of the date, operator, hypothesis, experimental protocol, maybe equipment used. Then you'll have the actual raw data itself, and then you'll have process data into information. So if you're trying to do papers, patents, being able to get hold of this stuff pretty quickly and see both the process data, the raw data, who did it, the experimental protocol, these are all useful things, and they're all in the same place. I said it earlier on, but at the moment I think scientists are mostly left to their own decision as to where they're putting this stuff. But of course, if you're the principal investigator, the CEO of the business, the CSO of the business, the patent attorney, you really want to get at this stuff and you've got to know where it is. Otherwise, the experimental effort, which we call the ENV, can have a value of 0. Whereas if you had 3 scientists in a lab and they're all well coordinated, then the ENV for that could be 3. If you have 5 scientists in a lab and they're all well coordinated, the ENV for that is 15. And it's not just electrochemical data as well. You can also put images and videos up there as well. I'm not going to click on the tools section today, but Julie actually also allows for the analysis of data. And then now at the moment it is particularly suited to doing electrochemical analysis. But I just want, at the moment we're treating it just as really as a empowering tool for making sure that everyone's well connected in an experimental network. But there's also another section which is tools. And when we first started off on Julie, we were really emphasizing the tools section. But now I want to emphasize really it's a single place where all the data can be put. You can collaborate internally, you can collaborate externally, you can share with people. They don't have to have Dropbox accounts or Google Drives or OneDrive, and it's free. And if you're working with ZP, it's super useful to have these accounts. Just lastly on reports, I've said it already, but it's really important. All those reports are searchable. So collaboration, viewing and sharing. So you have your clusters, but by just right clicking, you can actually invite people to those clusters. So you can start a project which is C-reactive protein, and you could be, oh, this is a really good point. I just want to pick up on something that Aftab has said. He's right. He's also said that Aftab is right, that this is something that's really missed at the moment. Through Julie, you can see if you have a academic collaborator in India, or you're in India and you have an academic collaborator in the UK, you can see the real-time progress of those scientists. And that is unbelievable. I mean, once upon a time, you'd have to have, meetings. Those meetings are now gone online. Everyone gives a progress update. I get it. Those are really still useful. But to get a sense of what's actually going on in the collaboration is really useful. If you're doing a project and one person's making you gold nanoparticles, you can see the effort going on because you need those gold nanoparticles in order to make your biosensor. So it's really useful to see what they're doing and how it's going, even when you didn't have to bother them by contacting them. So it is exciting to have the live updating. And you can do that by creating a cluster, sharing the cluster with people, and at which point then by sharing it, they'll be able to get in there and see what's actually going on. So a single person, no collaboration, an EMV of 0. Two people together has an EMV of 1, because there's only one connection between them. Bring 3 together through Julie, you have an EMV of 3. Bring a 4th into the mix with them, and you have an EMV value of 6. And bring maybe another 2 into that mix, so you now have 6, and you have an EMV value of 15. And this ENV value just keeps on increasing. But if you don't have well connection or good connection, then you will not get the true value of this. So so a number of people in the network is 25. You can actually have an ENV of 300, and only by raising it to 35, you could end up having an ENV of 600. I would say that European projects like a Marie Curie or a Horizon 2020, they can easily have this kind of number of experimentalists in the network, but I can assure you that they can't see each other's live progress through the electronic lab notebooks. They can't see it. So let's talk about internal collaboration. So at Zimmer and Peacock, we have, many businesses these days. Many businesses actually have consultants all over the globe. ZP is no different. So within internal collaboration, we could have, for example, a site in Norway, which we do, and a site in Coventry. We could have 3 scientists working there, all using Julie with an EMV of 3. 3 scientists in Coventry with an EMV of 3. If we connect these 2 teams, I've been at really large companies, and the connection between teams that were supposedly on the same project but geographically separated, there wasn't good connection between the R&D efforts. But if we connected those 2 teams correctly, the ENV goes to actually 15. So it is really powerful to, I'm really thinking a lot about India and Asia and North America these days, because this is where our collaborations are. And so it is powerful to have all these people connected through, one system. And then when you bring in a 3rd team that also has an intrinsic value of ENV of 3, and you bring them all together, that entire network now has an experimental network value of 36, and I think that's just really powerful. And I mean, I've made the point already, but it's not unusual to have, Europe, maybe, somebody in Australia, maybe somebody in North America. Once upon a time, seeing each other's lab books was impossible. Now, through people, I know what people say, I've said it already, OneNote, G Drive, Dropbox, that does make things easier, but it doesn't structure the data, and also it also makes it assume that both people, one person might have Dropbox, the other one might be on G Drive. On a personal level, you might have both. I get it, But from a company perspective, it's actually a bit of a problem because most companies don't have G Drive and Dropbox. They have one or the other. So that means that if you're trying to do a collaboration with a company, and one's on G Drive and one's on one's on Dropbox, and they share, what they're going to end up doing is probably end up putting data into people's personal accounts, not corporation accounts, and then you've really lost control of custodianship of data, and that's a real, let's say, problem. But if you have all these people all able to contribute up into Julie, then a lot of those problems go away. And I want to just say hi morning to Ahmet. Ahmet, thank you for connecting with me on LinkedIn. I saw your messaging, and we can chat about that later on. So I do believe really sincerely that if you want to collaborate, or you just want to have your own R&D effort more efficient, get a Julie account, start putting your data up there. It allows you to share with external people as well. So just finally, you can find Julie at julie.zimmerpeacock.no. It's easy enough to just sign up, using use your email, create a password, and then you've created yourself a Julie account. So I'll back up today and say, a lot of the time in the ZP Developer Zone, we talk about the details of making biosensors. But what I wanted to talk today was really about a strategy for making sure that your biosensor development was actually as efficient as possible. And the way you make that biosensor development efficient is you have smart people doing good experiments. But you have to have smart people doing good experiments who are highly connected. And as Aftab said, there's nothing more exciting than being able to see what's actually happening in the lab in real time. You could be up in your office, you can be on your phone, you can be somewhere else, but seeing what's happening and getting a sense of progress. And as I say, a lot of modern research is connected. One person might be making a nanomaterial, which another person is going to utilize. So the person who's going to utilize that nanomaterial might want to see how the progress is going. And the person who made the materials might want to see how it's being utilized in an actual device. And so both sides would quite like to see each other's data. And I think this, we live in a collaborative world now, and I think Julie's really just part of that new movement rather. So thank you, Aftab, for joining me this morning. Thank you, Ahmet, for coming online. It was great for you guys to do that. And just spread the news regarding Julie, especially in your respective countries. So I think there it'll make a real difference, especially for people who want to collaborate with us. All right, guys. I want to say thank you very much for coming this morning. I realize it's in the middle of a big holiday season for many people, but appreciate it. Let me just say thank you online, and we'll take it from there. All right, take care. Bye-bye.